This is a flash chromatography instrument. It is essentially a fraction collector with a low pressure column for separation and a dual detection system, UV-Vis and ELSD. ELSD stands for Evaporative Light Scattering Detector. It is essentially a tube in which minuscule droplets of samples scatter a beam of light. The droplets are formed by mixing the sample in solution with air and forcing the resulting solution through a nebulizer. The ELSD component of this instrument makes it particularly desirable for separations involving components that are non-UV active, such as terpenes and small aliphatic organic molecules. Prior to using the flash chromatography instrument, prepare your sample in solvents. All solutions must be particle-free. Introducing particles into the fluid path will cause hardware failure. This is especially important when changing the solvent bottles, as this is the easiest way to introduce unwanted particulate matter. Any samples containing particles should be screened before being injected. However, most columns are equipped with a foam stopper to prevent unwanted particulate matter from penetrating the silica. When starting the instrument, first open the compressed air tank. Check that the pressure is at least 60 psi. The instrument requires a pressure of at least 60 psi to operate. If the pressure is insufficient to perform a separation, change the gas tank, or, if you are not trained to do so, obtain help from an instrument specialist. The mobile phases will be pumped from these bottles. If you require a different solvent, ensure the instrument is not actively purging or utilizing solvent. Carefully remove the cap from the solvent bottle, and remove the ballast from the bottle. Replace the ballast to your desired eluent and continue. It's important to perform this step prior to equilibrating the column, as this ensures any remaining solvent in the line is purged from the system. Switch the instrument on. The power switch is on the left back of the instrument. When the instrument is powered on, consult the purification guide in the red binder to select your column. Columns are located in a drawer below the instrument or can be purchased from the manufacturer. If you are using an off-brand column, talk to the instrument specialist beforehand to ensure the column is compatible with the instrument. Connect your column to the instrument. Interchem columns are not Luer-Lock equipped columns. However, some column brands utilize the Luer-Lock mechanism to anchor the column to the instrument. If the column you are using has a Luer-Lock connection, ensure it has been secured to the instrument sufficiently before proceeding. Move the clamp out of the way. Then insert your column and twist clockwise to secure it. Move the clamp back. Ensure the fit is tight, but not too tight. All fittings are finger tight only. Do not over-tighten, as you may strain the plastic connection between the column and the instrument, resulting in column failure. You must have a column installed for every run to prevent damage on the hardware. This instrument has an option to utilize a pre-column for better separation. If you are utilizing a pre-column, consult the manufacturer's user guide for appropriate technique. Check the level of fluid in all bottles. Some solvent bottles are equipped with sensors to ensure the solvent level doesn't drop below a fourth full. However, these sensors do not always work, and it is important to check the solvent level before running a column. Solvent bottles should be more than 1/2 full, and the waste containers should be no more than 1/2 full. This is the main screen of the user interface. Before and after you start a run, you should purge the ELSD, even if you are not utilizing this component of the flash chromatographer. Click on the faucet icon and select ELSD Purge. Do a visual check for fog inside the ELSD ampule. If you do see fog, then the nebulizer is clean. Stop the purge after 15 seconds using the red square icon. You're now ready to set up your experimental parameters. When you're ready to run your column, create a new file method by clicking Setup and the method wizard. Here you have a few options, but the easiest option by far is to create a new method. When you hit create a new method, hit the next key and insert a title for your sample. Here we're just going to do test. We're also going to call this test 1 for the sample name, as you can run multiple samples on the same column. Select the column that you've chosen from the drawer from the drop-down menu. Apply the flow rate for that particular column as per the instrument manufacturer's guide and move forward. Select up to 4 different solvents. If you don't see your solvent listed, you can always use a dummy solvent and then go in and add it to the system later. As long as the solvent bottle is changed, the instrument will utilize the appropriate solvent. When you've placed your column on the system and entered the sample name and solvents, you then need to select your equilibration method. So typically, when you're using an instrument brand column, you click column volumes, and that will equilibrate the column up to the amount of column volumes listed here for the column you've chosen from the drawer. You can also opt to do a time equilibration, which is typically used when you're using an off-brand column. Move forward and click wait for injection. You want to ensure that your equilibration injection mode is set to wait for injection. The instrument will run your method before you've injected your sample without doing an equilibration if this is not set appropriately. Stop mode should always be set to pause. And then here in this particular menu, you can select a gradient ramp, isocratic, gradient, or any other type of style you want to choose, and change the option based off of this icon right here. If you're using a gradient method to separate your sample, you can go ahead and click add here to add a different section or gradient. Changing the solvent percentages is as easy as clicking on 0 and entering the percent for each different solvent. So you can have a variable change in gradient over a course of time or column volumes listed here, and then actually go ahead and view in a graph how that's going to look over time. Once you've selected the appropriate gradient for your separation, click the next button. There are 5 different channels you can use for UV active components. That UV wavelength that you select at the beginning at the start of every channel can be adjusted to what you need. Typically when you're doing organic type separation, your wavelengths that you should collect at should be 254, and then you can select collection and a threshold, and then you can add another channel for UV, and 365, and also select a collection. If you're performing a separation of non-UV absorbent compounds, select the ELSD option here, and also hit collection. The threshold should be adjusted to the amount of sample in your mixture. Have a higher threshold for a more concentrated mixture, and a lower threshold for a less concentrated mixture. It's important to get the threshold right, as you don't want the instrument to trash your sample if it doesn't reach the threshold, but it has a very low absorbance. Moving forward, select the racks that you need. Click on the top of the rack and select the 22 milliliter option. Depending upon the amount of sample you have, you might need to use more than one rack, and that can easily be adjusted by tapping on the square box. The collection threshold or collection mode should be set to what you please. So threshold would be as it reaches the threshold of absorbance that you've set, it will collect at that threshold. Volumes can either be full or adjusted to user desire. So you can type in for a 22 milliliter test tube any volume that you want within that range for each threshold collection. Local minimum is a finicky option to use. If you do select local minimum, it's typically when your compound doesn't separate very well even after an optimized solvent system and column size has been found. So if you have overlap of your 2 different components in a mixture, you want to select local minimum, as when the instrument detects a dip in the absorbance, it will go on and move to the next fraction. So for no local minimum in a component or a mixture where you've gotten good separation and your sample and your desired compound is separated from other impurities, select no local minimum, as it will avoid unnecessary fractions along the collection rack. Hit finish, and you're ready to run your column. The instrument will automatically equilibrate your column by pressing the start button here. So once it goes through this 3 column volume equilibration, which you can see as a black arrow, you're going to go ahead and remove the check valve by twisting this little black component here, lifting and placing your syringe onto the valve, and then injecting your sample. Remove your sample and replace the line, and twist and make sure it's secure. Press the start button after it's finished equilibrating, and it will run your method. So you just finished your first run on this chromatographer. Congratulations! The next thing you should do is go to the little faucet icon and purge solvent through your column and through the instrument so that there is no remaining compound in the instrument. So a typical procedure for this is to purge 100% of your non-polar solvent for 10 minutes or so, or however many column volumes you decide, and then purge 100% of your really strong solvent, that being ether, ethyl acetate, or whatever other strong solvent you're using, for the desired amount of column volumes. This really does ensure that the instrument stays clean and the next user of the instrument doesn't have to deal with any overlap of your sample and the components and their sample. When you finish running your column, it's important to purge here the ELSD split purging once again before you power off the instrument. You can save your data by clicking the Save icon or going to File and File Management, and it gives you an option to save your data. When you're done with the software, close this application and power off the instrument. You should hear the air valve turn off. Shut down the CPU. It's important to wait for the computer to shut down fully before you actually power off the instrument. Once the CPU has been powered off, use the power switch located on the back left of the box to power off the instrument. Close the air valve on the air tank